Hello everyone, welcome to Young Innovators. We had discussed about motors and their working principle in our previous video. Hope all of you understood the video and enjoyed watching it. Today we shall look into one more electronic component that has major applications in almost all the electrical circuit. That is a switch. We have seen switches all around our homes, offices, schools, and any other place we go. They play a major role in controlling the current flow in the circuit. What would be the joy if we did not have any button to press in a blinking circuit? Or how would you tell the robot to start working if we did not have a switch? A switch can be defined as a device that is used to break a circuit and interrupt the electrons from flowing in the circuit. We all know that when the switch is on, the circuit is termed as a closed circuit, and when the switch is off, we call it as an open circuit. Switches don't need any equations or formulas to work. They just do the task of choosing between the type of circuit that is to be built. It is considered to be binary as it can only do two tasks. Either it can be on or it is off. We all have come across a push switch and a slide switch, which provides a path for the current to flow when it is pressed or slided respectively. We shall look into few more switches. Now, we get two types of switches. 1. A mechanical switch. 2. An electronic switch. Mechanical switches are those which needs physical operations of pressing. Electronic switches are those which work with no physical action from the user. Today, we shall see different types of mechanical switches and understand how they work. Switch must have at least two terminals, one for the current to enter and one more for the exit of the current. Most of these terminals are referred as throws and poles. The number of poles in the switch defines the number of separate circuits the switch can control. So, if a switch has one pole, it can control only one circuit at a time. We also have two-poled switches. A throw in the switch defines the number of positions the poles in the switch can be contracted. For example, if a switch has single throw, it means that it can control only one circuit. Knowing about the poles and throws, we will further discuss its specific classification. We commonly find three classifications based on the poles and throws count in a switch. That is single pole single throw, single pole double throw, double pole double throw. Single pole single throw or SPST switches are the one that has only one pole and one throw count. They have two terminals. It can be on when it is pushed to one end and off if it is pushed to other end. These are the switches that is found in our places. This is how they look, and the internal connections of the switches are as shown. Now looking at single pole double throw or SPDT switches, they have three terminals, of which one terminal is common. The slide switches that we use can be a perfect example for this. Next, we have double pole double throw or DPDT switches. Two sets of SPST switches form a DPDT switch. Basically, two SPDT switches which can control two separate circuits are always switched together by a single actuator. DPDT switches has 6 terminals. Consider the following connection of the switch. Connections A, B and C form one pole of the switch, and connections D, E and F form the other. Connection B and E are common in each of the pole. If a positive power supply enters connection B and the switch is set to the topmost position, connection A becomes positive and the motor will rotate in one direction. If the switch is set to the lower position, the power supply is reversed and the connection D becomes positive, then the motor will rotate in an opposite direction. These types of switches are mainly used in various motor controllers where speed of that motor is to be reversed or reduced. We get many other types of switches like reed switch, toggle switch, rocker switch, microswitch, etc. We shall look at a microswitch now. Microswitches have either a small push button or a lever in order to start the switch. They require very little physical force in order to operate and are ideal for small scale projects or application. Here is the circuit connection showing the working of a microswitch when the lever is unpressed and when it is pressed. The input is given to the common terminal. The switch is in closed position. When a slight force is imposed on the lever or when it gets pressed, the C and NO terminal gets connected and the blue LED glows, as there is no contact between the C and NO terminal. Depending on the application, we can use the SPDT microswitch in NC or NO mode. Based on our requirement, we can select the switches and make the circuit. Can all of you go back to Tinkercad workspace and list the number of switches that are present there? We shall see more about robots that work on switches in our next video. Thank you for watching.